What up, dudes? Today we're going to be covering function notation and talking about how functions work. And what I'd like to do is get over to graphs. And graphs are really important because in chemistry, which you guys are probably in as well, you guys are going to be learning a lot about graphs and how to interpret them and everything. So we're going to do some thinking about this stuff and we're going to get through this as quickly as possible. Hopefully this will help you out on your homework. I'm going to basically be doing, I don't know, why don't we try the odd problems? Or I'll take a look at exactly which ones we should do and then we'll go through that. Sound good? So I'm on page, whatever this page is. I think it's, I don't know, it's page 18. And we're looking at function notation. And remember what I told you is when I wrote this down like this, do I have room over here? So it's R, M. This means R as a function of M. So what that doesn't mean R times M. We're talking about, I guess, let me see. Suppose RM represents revenue in dollars to receive in minutes. Okay, so what we're talking about is this function. I mean, just writing down RM kind of teaches you, it tells you a lot about the function. It tells you R stands for revenue, M stands for minutes. So apparently minutes is related to the amount of revenue. If you wait so many minutes, or if you advertise for so many minutes in our TV spot, then you'll get so much revenue back. Does that make sense? Yes, no? So that's kind of your shorthand way of notating it, but please don't think that that's R times M. Now let's see. Use the function notation to represent the following statements. The first one has been completed for you as an example. Note there is no connection between the individual columns. In other words, you should assume that each of you are advertising a different time frame for a different product. All right, whatever. Okay. The revenue we received from 3 minutes of advertising is $500 more than the revenue we received from 2 minutes of advertising. So the way you would write that down is R is a function of M. And it could be some function. I have no idea, but it's like I don't know. You could say like 3M or something like that. R is 3 times M. So if you advertise, or let's make it 3,000 times M. So what that means is if you advertise for 1 minute on our TV show during on our program during the Super Bowl, then what you're gonna get is you're gonna get $3,000 back. It's gonna generate $3,000 worth of money. Okay? Or let's make this a high school football game because you get a lot more revenue for 1 minute of advertisement on the Super Bowl. All right. So I'm a high school football game TV broadcaster, and I say if you advertise for 1 minute, you get $3,000 back. Sound good? So this is the function. This is the function that we plug it into. Now we don't necessarily know what that function is, so we just kind of leave it as RM. And then if I say, okay, well, the revenue of 3 minutes is going to give me some number. R3 is going to equal some number. And the revenue of 2 minutes is going to give me some number. And they told me that the revenue that I get from 3 minutes is going to be $500 more than the revenue of 2 minutes. So all I got to do is add 500. And these are equal to each other. Does that make sense? I mean, I know I did the example problem for you, and I basically just kind of went straight through that. But that's the way you would kind of approach that in functional notation. So you would say R3 is equal to R2 plus 500. We cool? Number one, you didn't need to write anything down because the problem was given to you already. The solution, the example problem was given to you. All right, let's try number 3 because I'll let you guys do number 2. Take a picture. I'm going to erase. I feel like there's a phone call coming. I don't know. Anyway. All right. Let's try this one. Number 3, the revenue we receive from 5 minutes of advertisement is double what we receive from 2 minutes of advertisement. So we're working with 2 numbers here. And I got a question. Okay. Here's my question. Is this a function or a number? Is this that I wrote down, is that a function or a number? It's a function. Now this right here, is that a function or a number? This actually represents a number. Not because there's a number in there, but it's almost like it's kind of like, remember what I told you, what is the difference between a function? And I went back to the chicken katsu story. Do you guys remember the chicken katsu story? I know I told it on Wednesday last week, and I told it yes on Monday as well. But what I'm saying is basically this is like katsu. This is the process, and this would be like one of these you can eat. The other one you can't. This is an actual dish. This one you can't. This one just represents the process that you would take it through. But once you give it something, then you can take it through that process and then it will spit out a number. What's going on, Brandy? Once you give it something, it will take it through that process and spit out a number. So when it spits out that number, then it becomes an actual thing you can touch, hold, feel. It's a number. Does that make sense? So anyway, we're dealing with the number R5, right? That's one of the numbers we're dealing with. The other number we're dealing with is R2. We don't necessarily know what R5, the actual number is, but we know that once you give me the function, I'll tell you what the number is. I'll tell you what, you know, what to do with it. Yeah? So R5, R2 are two different numbers, and then let's see. The advertising of 5 minutes is double what we receive of 2 minutes. So if I multiply this one by 2, then those are equal. So I think the solution would be R5 equals 2 times R2. Does that make sense? Do you guys see how that works? This is for number 3. This is 1.6. We cool? Someone else say yes or no, or I don't know. I hate you. You're ugly. Your breath stinks incredibly. I can't stand it. Now Elijah could be the only one who says that though, because. But I want somebody else besides Elijah, because he's here. He's actually behind this wall right now. And by the way, for those of you who actually want to see what the picture is that I'm showing, it's actually a self-portrait of me, flipped sideways, because I needed a black background. Anyway, you guys get it? We cool? Awesome, awesome. I'm getting words back. That means you guys actually understand. You can hear me. Good. I want you guys to be able to talk back with me. Good. Awesome. I'm going to erase. So you guys feel like you get functional notation yet? Why don't I do another one for you? Wait, what time is Miss Agvanlock's class stand for? Or slide for? Oh, you guys have to leave physically to actually drive down here to get to Miss Agvanlock's class. Is that what you're saying, Kaylin? I see. Yes, you can totally leave early. I'm just going to go until 10:55. Okay? And we'll work the system out later. Alright. Alright, so let's do number 8. If we triple our advertising, our revenue will double. Do you guys know how to do that? Elisha, you want to come up and be an example? Do a problem up on the board for us? Okay, say no. That's fine. All right, check this out. If we triple our advertising, our revenue will double. Okay. So this is the revenue we get for the number of minutes. M. Does that make sense? So if I plugged in 5 in here, that would be the revenue we get if we advertise for 5 minutes. We cool? If I plugged in 5 for M. How would I represent this if I wanted to say I want to triple my advertising minutes? What would I plug in here instead of just M? $3x or times 3? Exactly. This represents tripling your advertising minutes. By the way, I'm doing number 8. So if you plug in a 3M instead of an M, that's talking about tripling your advertising minutes. Does that make sense? Now the revenue that we had to begin with was just RM. This is the revenue. This is how much it would be triple. This is regular revenue. This is triple. Triple. This isn't triple revenue. This is triple minutes. I'll make this word M. So this is the amount of revenue we get back for the regular amount of minutes, and this is the amount of revenue we get back for the triple amount of minutes. So if I want to write down, if we triple our advertising revenue, or if we triple our advertising, our revenue would double. This is what triple your advertising means. It means it's saying this will be twice what this is. Does that make sense? The result of this will be twice the value of the result of that. So you have R3M equals 2 times RM. Am I making sense here, or am I talking crazy? What do you guys think? I'm looking at 8.1. So I'm looking at this guy right here. This problem right here. Yes, no, maybe, makes sense. Do you guys have it written down? Elijah? Good? Awesome. So hopefully that will kind of let you hang with the rest of those. Let's move on. Alright, so let's see. I'm going to move it up. There we go. Let's reverse the process. Alright, right? For each of the following, describe the context of their meanings. Okay. This actually seems kind of fun. We're going to do number 9. You guys ready? Let me erase. First of all, I need Windex. Alright, let's get this party started on number 9. I'm doing number 9. Okay. Doing this guy right here. What is this saying? What is this problem saying? Elijah, or you know what? I'm going to have to pick on people here. I want Travis, I want you to chime in here because I need you to talk back to me. Johanna, you're doing a great job at talking back to me. I want you to kind of describe for me in a sentence. I'll tell you what, if you guys want, I'll do your homework. I'll do this part of your homework for you, but I'll help you out with the first one. You guys help me out with the second one. Sound good? Sound fair? I don't want to just be the talking head up here giving you all the answers. Alright, you ready? So check this out. What this is saying to me is the revenue received after 5 minutes is $100 more than the revenue received after 4 minutes. Instead of writing that down, I'm just going to type it up. I'm going to chat it back to you. The revenue received after 5 minutes is $100 more than the revenue received after 4 minutes. of advertising. That's what I would write inside of that little sentence right there, or that little box right there. Because this represents the revenue after 5 minutes, the R4 represents the revenue after 4 minutes. The $100 is the difference that they make. You would have to add $100 to the revenue of 4 minutes to make it equal to the revenue of 5 minutes. Does that make sense? All right. Number 10. You guys type up the sentence. I'll give you some time. All right, Elijah wrote, the revenue after 6 minutes is $200 more than revenue after 5 minutes. That's exactly what you should do. All right, so you guys think you guys can hang till 15? I'll tell you what, why don't I give you another freebie? I'll do number 12. Okay, we're doing this one right here. You know what, I'll do number... I did something like number 12, so why don't I do number 13 instead? I'll give you a hint. Number 12 is just like number 8, which we solved on the previous page. But it's a little bit different. Anyway, number 13, that one looks... So I would say, here's my sentence. Ready? If you advertise for 5 more minutes, then you will make $1,000 more in revenue. Because RM plus 5 represents, RM is how much you would normally advertise, right? And RM plus 5 represents what you would normally advertise plus 5 more minutes. So instead of putting in a straight up number, I just put in the letter M, because that basically I'm saying, like I tell you, hey man, if you advertise for 5 more minutes than what you would normally do, you would make $1,000 more, and you'd be like, I want to advertise for 3 minutes. And I'd be like, dude, but if you advertise for 8 minutes, you make $1,000 more. You get it? Does that make sense? That's how I would read that. If I look at that, I see. And what's cool is, and this what blows my mind, you can actually write that entire sentence in that line. RM plus 5 equals RM plus 1,000. And from that little piece right there, I'm able to kind of get this whole sentence to say, look, if you advertise for us for 5 more minutes, you can make $1,000 more. Boom, I said all of that in less than, like, in this small little writing right here. That's what makes functional notation pretty cool. That's why we're so lazy in math, because we hate writing. Does that make sense? Number 15 looks tough. Instead of giving you the answer, instead of writing it down, why don't we just talk about it? I'm just going to talk about it. You can watch the archive if you want, if you don't get it. Provide a numeric answer for R10. If you know that R4 equals 1,500 and RM plus 6 equals RM plus 1,200 for M greater than 2. Whoa. Okay. Okay. How would I do that? Any thoughts? I know what to do. I'm just wondering what your thoughts are. All right. What are your thoughts? You can tell me IDK. You can tell me that be cray cray. You can tell me I have no idea what to do. You can tell me exactly what to do. I'm not saying all of you will not know what to do. I'm sure that one of you might. Just tell me what you're thinking right now. All right, I don't know from the evangelist or Joanna. I've got, well, 1200 equals 1 minute. I would multiply that by 6. What do you mean 1200 equals 1 minute? I'm curious about that. I don't know. I like that you're trying, Elijah. And I like, Joanna and Travis, that you're admitting that you don't know. That's totally fair. All right, you ready? I'll kind of think about I'll think about how to guide you through this. What I would do is, if you know what R4 is, I would plug in, see, what R4 represents is usually, okay, this is number 15. Usually we have RM, right? Right? But this time we're replacing RM with, we're replacing the M with a what? With the number 4. Right? And we were already told that that's equal to 1500. So the way I would kind of go about that is I would plug in 4 into that bottom equation and see what I get. That would give me R10 equals R4 plus 1200. Right? I'm just kind of taking you through my thought process. My thought process is like, if I know R4, I'm going to plug in 4 for the M on the bottom one and see what happens. Well, luckily, it gave us R10, which is what we were looking for in the first place. And we have R4, and we know 1200. What is R4? It's 1500, so you just plug that into there. It looks to me like it's 2700. Oops, I told you the answer. Coolios with that? I'll admit to you that it's tough. It's a weird question. It's weird to wrap your mind around these kinds of things, but I am excited about that. Anyway, what else do we got? Let's see. Homework number 2. Why don't we do, I'll do problems 2 and 4 and you can do the rest. What? He's actually doing our homework for us? Yes. Show up for class. Watch the archives. Because if not, you got to do all of it by yourself. And to that I say, have fun. Elijah's like, you're the only teacher I've ever had who actually does the homework for us. Yeah, but I think I give you enough problems to have on your own as well. You know, I don't do all of your homework for you. I do less than half of it. Right? Does that sound fair? Alright, anyway. Linear function dt is defined as the distance you still need to travel to arrive at your destination t minutes into your trip. Okay, fine. So, can you imagine what's going on? Elijah, we're taking a trip. Ready? Go. We start the clock. Boom. How far did you travel? Well, you can basically say, all right, dt is the distance you travel. Assuming you're traveling at a constant speed, is dt slope positive or negative? Explain. What are your thoughts? Positive or negative? It's a 50-50 shot. Type in plus or minus. Is it positive or negative? Slope, that is. Joanna says positive. All right, everyone's saying positive. Yeah, I would say that's absolutely correct because it's talking about your distance from a spot. Now, I would say that you got to be careful because they said the word constant speed, right? Like we're looking at this problem right here, number 2. They said the word constant speed. If they didn't say the word constant speed, then I would say that your slope could actually be positive or negative. Because we could be like, Elijah, we're going, ready? And now let's pretend that we're tracking my distance from this side of the screen. So I can be like, all right, I'm going, and then I could stop. And then there's no slope. And then my line would look like this. right? It would go up, 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 and then stop, and then just have this constant time. Because if this axis were t and this axis were d, then it would just go, and that would have no slope. And then I could actually go backwards and go that way. But that wouldn't be moving at a constant speed. If I'm moving at a constant speed, it would just go up like that. Does that make sense? So I would just be walking this way. We cool? I need you guys to chime in. Come on, man. There's a lot of waiting happening if you guys don't talk to me. All right. Now, I got a question for you. I'm just curious to know if you guys think about this. What if I were walking backwards? Would the slope still be positive or negative? This is like part 2B. I'm just kind of like, let's dig deeper into this. What if I were walking backwards? Elijah's saying it's negative. What do you think? Joanna? Travis? Sam Cash? Big money? Joanna thinks it's negative. Awesome. What about you, Travis? What's your thoughts? Negative. Awesome. Awesome. Great job. All of you are wrong. Think about it. If you start at 0, and I'm walking, right? And I'm 2 feet in front of the pen, then my distance is 2 feet, right? It's positive 2 feet. Do you agree? But if I start at 0 and I'm walking backwards, this is more of a physics question. This is more of a are you guys thinking question. If I start at 0 and I'm walking backwards, what is my distance? It's still positive 2 feet. The distance I am away from the pen is still, I would take out my meter stick or my tape measure and I would still measure 2 feet. Does that make sense? So your distance is still getting positive because it's getting a greater distance away. Even though it's, I'm going to go forward or backwards or to the right or side or up and down, whatever. It doesn't matter because my distance away from the pen is constantly getting bigger. Does that make sense? Do you like that? You like that logic? Huh? Huh? Does that, yeah? Yes! Awesome. Sam, can you hear me? Awesome. Sam, we're kind of developing this culture in our class. I don't need you guys to chime in and talk to me every single question. That's the way I run class. That's the way I roll. That's what I want to train you guys to start doing. So anyway, we're getting into function notation. I'm actually doing 2 problems out of your homework for you. All you got to do is just write down these answers and you can turn them in and then be happy, blah, 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 blah. All right, cool? Let's do number 4 for you. We're talking about how to answer these questions, I guess. All right. Suppose PT represents the amount of money in your savings account after T years, or T years after depositing the initial amount. All right, awesome. So your P probably represents the word profit. Your T represents time, measured in years. I'm assuming this is probably a bank account that acquires interest. Use the function notation to represent the fact that the amount of money in your account after 5 years is $400 more than your initial deposit. Okay. So, do we know exactly how many years we're dealing with? Or do we know what the exact amount of the initial deposit is? We don't. We don't. We don't know the amount of his initial deposit. That's PT. But we don't know exactly what the value of PT is. That's a T, by the way. Right? We do know that we're dealing with P. Do I just put P5 in here? I guess you could, yeah. Yeah. I take it back. We know that the profit that you got after year 1 is this. And the profit after year 5 is this. Which one's bigger? P1 or P5? The profit after year 1, profit after year 5. And actually, I realized this might be a little deceiving. I think that it probably should be P0, because it's your initial deposit is when the amount of money you initially put in, not after 1 year of it being in there. So we should probably put a P0 there. Yeah. So what we know is that the P5 is the one that's bigger, so we need to add $400 to this one if we want them to be equal, right? Because this one's $400 more, so if I add $400 to this one, then they will be equal. So the way you write it down is you can just say P5 is equal to P0 plus 400. So it looks to me like you made $400 on your initial investment, which is pretty good. You leave it in for 5 years, get 400 bucks. You didn't do anything. You didn't do any work. Your money made that money for you. No, that's called investing. It's a big deal. You should learn how to do it. I don't know how to do it. If I did, I'd be rich. I'm not rich. Mr. Dahldays, poor teacher, man. I'm on welfare. No way I'm rich. Anyway, I don't know. Am I griping? Am I just complaining? I should move on. All right, that's lesson number 2. Let's move on. Let's upload a different web conference and we'll see what we got. Give me a second. Give me like 5 minutes. How's your brain? Do you guys need a little break? You want to take a little 5-minute break? If you say no, then I'm just gonna go. Keep going. Come on, be bold. Ask for it. Wait, Elijah, you don't want a 5-minute break? None of you guys want like a 5-minute break? Really? Well, I want a 5-minute break, so tough. Deal with it. 5-minute break, folks. Give me till 2:30 or 10:30, 23, and I'll have this next part set up for you. Cool? Yeah. Sam, I'm going to help you download the PDF file right now. I'm going to do it